So, welcome back to my channel. And by the way, I'm Gutierrez Donald Day from 2107. And for today's video, I'm going to answer all activities for this chapter. So, which is chapter 4. So, chapter 4 entitled Network Access. So, first thing that we need to do is read this before we answer the activities for this chapter. So, to support our communication, the OSI model divides the functions of a data network into layers. So each layer works with the layers above and below to transmit data. So two layers of the OSI model are so closely tied that according to the TCP/IP model, they are in essence one layer. So those two layers are data link layer and the physical layer. So on the sending device, it is the role of the data link layer to prepare data for transmission and control how that data access the physical media. So however, the physical layer controls how the data is transmitted into the physical media by encoding the binary digits that represent data into signals. So on the receiving end, the physical layer receives signals across the connecting media. After decoding the signal back into data, the physical layer passes the frame to the data link layer for acceptance and processing. So this chapter begins with general functions of the physical layer and the standards and protocols that manage the transmission of data across local media. So it also introduced the functions of the data link layer and the protocols associated with it. So in short, these sentences here in the start is it I think it's a summary for this chapter, a bit summary for this chapter. So let's answer all the chapter activities in this chapter. So let's do this. So the first activity that we have for this chapter is entitled Physical Layer Terminology. So instructions, description of the physical layer are provided in table. Drag each physical layer term to its description. So we need to drag the physical layer term to the correct physical layer description in table here. So let's start. So the first we have a media that uses patterns of microwaves to represent bits. So media that uses patterns, so it's wireless. So the capacity of a medium to carry data, so it's probably bandwidth. So media that uses patterns of light to represent bits, it's fiber optic. So a measure of the transfer of bits across the media, it should be true. So media that uses electrical pulses to represent bits, it's copper. So you have successfully matched each physical layer term to its description. So that's all for this activity, and we are done with it, and we need to move in the next activity in this chapter. So the next activity for this chapter is entitled Copper Media Characteristics. So we have the instruction, we have a UTP, STP, and coaxial copper media characteristics are provided in the table. So click the appropriate field to match the characteristics to the media type. So we also need to read before we answer. So let's start. So let's read first. So attaches antennas to wireless devices can be bundled with fiber optic cabling for two-way data transmissions. So it's coaxial copper. So the next one is we have counters EMI and RFI by using shielding techniques and special connectors. So most common network media UTP, I think it's UTP. So terminates with BNC N type and F type connectors. It's coaxial. So let's check if our all answers are correct. So it's correct. So we need to move on the next activity in this chapter that we have. So we have a last two activity. So the third activity that we have is fiber optics terminology. So it is the same in the first one that we have. So the instructions here, descriptions of fiber optic media are provided in the table. So click the appropriate field to the match description to the fiber optic cable type. So in here we have a two choices here, which is multi-mode and single mode. So we have a 6 given here. So let's answer this. Can help data travel approximately 1.24 miles or 2 kilometer 2000 meter. So it's multi-mode. Use light emitting diodes LEDs as a data light source transmitter. So it's multi-mode. So uses lasers in a single stream as a data light source transmitter. So from the word single stream, so I think it's single mode. So used to connect long distance telephone and cable TV applications. Is to connect single mode. So can travel approximately 62.5 miles or 100 kilometers for 100,000 meter. So it's single mode and used within a campus network. It should be multi-mode because a campus network is should be a more building, so you need to have a multi-mode. So let's check. So you have successfully matched each fiber optics description to its cable type. So that's all for this activity in this chapter. So the last one that we have in this for this chapter is entitled generic frame fields. So it should, you know, we have a part 1 and part 2 for this last activity. So this activity is generic frame field. So the instruction is to drag the generic frame field to its correct location on in the diagram. So we need to drag this generic frame to its correct location in this diagram. So let's start. So the thing first we have, I think it's header. Then the next is packet data. The next is trailer. And I think the last that we need is frame stop. Then if it is last frame start, so we have a frame start here. So after that we put a frame start, I think we need to put the addressing. So we need to know the type. Then you need to control. Then after control it, you need to have a data and error detection. So I do not know the correct answer here, but let's check if our all answers are correct. So you have successfully placed the order of generic field names in the frame. So that's for all in this video. I hope you understand and learn something from this video. So thank you guys for watching, and by the way, I'm Gutierrez Donald A.